Okay, I've set this up one more time because I want to show this experiment here should show that my theory is correct. My theory says that a magnet, if you saw my magnetism, that static charge goes in the south and it terminates on the north. It doesn't go all the way around towards the core like most things. And since it's going through twice as far to go, it's got to accelerate. That's why you get this side is fed from the south, so it doesn't need the charge coming in on the north, so the north is diverted around. So there's two opposite directions of flow here, and I want to show you how I can prove it. So this is my compass. It's my dad's old World War II. I don't know if you can see, it has an arrow for the north, a west and an east and a south, and the south is on the other side from the north. So anyway, the big end of my magnet is north, if you can see that. It moves the arrow part of the compass. And if I flip the magnet around the south, then the south, the little end is south, the big end is north. Okay, I just wanted to show you that. I guess you can see that. Big end is north. You can see the arrow and south. Okay. The point on this is I've got my wires, my coil set up. The wire closest to us goes to the positive of the meter. The wire on the far side goes to the negative of the meter. And you've seen me do this before, but I want to do it again because I want to show you something about this, how a magnet works, why it does that, and how it makes AC current become AC current. So I got the north sticking into the coil. Now, if you notice, when I push it in, I get a negative reading. So when I push the north in, it makes the charge go along the coil, out this wire, into the meter on the black one, the negative side, and then come back out on the positive. So I get a negative reading. And when I take the north, and here I go, 1, 2, 3, pull it out, I get a positive reading. So when I pulled the north out this way, with the north facing that way, when I pulled it back out, the charge went back this way along with the direction of the movement of the magnet to a positive reading. Very simple, makes sense. So when I pushed the north in, I got negative. When I pulled the north out, I got positive. So I'm going to spin the magnet, put the little end in, the south, let the meter settle. 1, 2, 3, push, I got a positive reading. So when I pushed the south in, the charge went backwards. The magnet was moving that way, but the charge went backwards this way to a positive reading. It reversed, and it's going to do the same thing when I pull it out. 1, 2, 3, I pull, and I get a negative reading. So when I pulled the south out, the charge went backwards this way into a negative reading. And the reason that does that is because the north is pushing away, diverting from itself, and the south is pulling into itself. So depending on how you orient the magnet to a coil, depends on which way the coil accelerates the gravity, which the magnet's automatically doing. And the point of this was not just to, again, show that magnets right here prove what I'm saying about my theory and doing it with this little tester. But AC currents use this orientation of the magnet to make alternating currents. You use the north side against it and it pushes, right? You use the south side against it and it pulls. And I'm going to show you on the AC part of my generator why this is true. What I'm telling you is true because of how it operates. And we'll move into that. Okay, on the AC system, I'm going to show you on my little dryer or washing machine motor, brushless, which I told you the magnets are like north, south, north, south, north, south, north, south as they pass by the coils. I want to make sure you understand and see that that's what's going on here. My compass will work with me. Sometimes it gets freaked out because they're so close together. Like you'll have a south, and it'll flip around to a north, and it'll flip around to a south, and north, and it'll flip around to another south. So if you see with the compass, it goes north, south, north, south, north, south. So we know we're doing AC current. We're pushing with the north, we're pulling with the south, pushing with the north, pulling with the south. So each one of these is going push, pull, push, pull. I want to make sure you understand that before I move on to metering what we're going to show on ions. And we'll move on. Okay, on this, I want to make sure you know that you got your north, south, north, south, north, south because of the magnets. The north make it push, the souths make it pull. That gives you your alternating AC current. I wanted to explain the bridge rectifier again. Anytime there's 42 coils, they're divided into threes, 14 on each. 14 coils to one wire, 14 coils to another wire, 14 coils to another wire. A, B, C, A, B, C, A, B, C. So all the A's go to one wire, all the B's and all the C's. So when all the A's are pushing, someone else is pulling, B's or C's are pulling, and back and forth. So it alternates. The bridge rectifier just takes anything that's pushing, any one of those three of the 14 or 42, 14 on each leg that's pushing, goes out this wire. Any of the 14 or 42 that are pulling comes in this wire. And most of your DC components of electronic current or electronic devices have bridge rectifiers, which the DC goes out, and that's what runs the components. Just like when you plug a wall wart in the wall to charge your phone or anything, it turns your AC, which comes in from the power company to your house. The wall warts turn it into DC. It goes one direction. Out this, charge the battery of your phone to come back. So most everything works that way. And a lot of things in your house will be AC, like your toasters, your oven elements, your oven burners on electric ranges, stoves. That runs AC back and forth. It uses the AC to heat up things because it's moving so quick that it just uses that quickness to heat up the elements. Your hot water heaters, electric hot water heaters, electric toasters, furnace, anything that's got a heating element in it. A lot of things run on AC, but anything on components like your TVs, computers, phones, anything that's got a smaller component inside it will use DC, which it just uses the push side. Any of the AC coming in from the power company, back and forth, push, pull, the DC rectifier, the rectifier turns it into DC. All the pushes go to the components in your device, your computer, your TV, or whatever, to fire it up, and then the other DC comes back, whatever's left out of whatever it uses. It hits your transformer. The transformer's AC, drops it down in voltage. Your bridge rectifier puts that whatever voltage. The push leg goes to the component, and the pull leg comes back with less than what went in because it used some accelerated gravity. And we'll move on. And I want to show you that the system is working. It still does work. Like I had showed you before, the far switch runs these bulbs back here, which are in parallel. They all come on at the same time. And the switch over here runs these three, which are in series, into this bulb, out of this bulb, into this bulb, out of this bulb, into this bulb, and back to the system. So I'll turn on the parallel or the series side or the parallel side. They're all three burning at the same time. A little harder to push. And turn that off, turn this on. And these are in series. Easier to turn. I got to turn a lot faster to get as much brightness. So I wanted to show you that the system is working. It is producing an electric current, which I say, my theory says, is nothing more than accelerated gravity, which is what these magnets are doing. They're just creating the copper coils to conduct that. And we'll move on. Okay, the first thing I want you to notice here is I've got both red positives into the positive of the meters on both of them. I've got this one set to 600 volts AC, and this one set to 600 volts DC. And I've got the AC hooked to two different AC wires. You got leg 1, 2, 3 AC. There's just push, pull, push, pull, push, pull. The other meter I have hooked to the positive lead, which is the DC positive, which is coming in this way, and the DC negative, which is going out. That way my meter can whatever's pushing out that leg is going to go out to the meter. Whatever's coming back is going to go into this leg. So they're both set up that way. This one is on AC for the AC side, and this one's on DC for the DC side. And as I turn the handle, watch the meters. We're both positive, and our numbers aren't too far apart. 40 on the AC side and 50 some on the DC side. And that's cool. So 40 millivolts. So now let me swap these leads here on the DC. Oops, sorry, lost my lead. Swap those, and I'm going to swap the AC also. So now we're swapped. Whatever we had, we've just swapped. As far as that goes. Same connections were swapped. And watch the meters. The DC side went to negative, if you see that. And the AC stayed positive, which I can explain that later. And I can swap my leads on the AC. I'll go, A, B, C. So I'll go A and C instead of B. I'll skip B. And the red's on A, the black's on C, let's say. And we'll do it again. I'll run it. And we've got negative on the DC and still positive on the AC. And I'll even swap this way to where now, let me hook it good, we are B and C instead of, at first we were A and B, then we were A and C. Now we're C or B and C. Change it all to the third way I can change it. And it still shows a positive reading. And it doesn't matter, I'm going to reverse the direction. And it's still the same on both. No matter which way I go, it's the same. So you get a positive reading no matter how you run AC, and you will get a positive or negative depending on DC, like I showed earlier. Okay, I've only got 1 meter hooked up, and I'm setting it to DC, but I have it hooked to the AC legs of my bridge rectifier coming out of my front load washing machine motor, which I'm using as a generator. And I showed you earlier why that the DC side would show up when I had 2 meters, one set on AC, one DC. The DC side showed positive and negative ions, or which way the current was flowing. And the AC side always showed an AC flow, which makes sense, AC is AC. But the reason being, and what I will show you in a moment after this is over, is why the meters do what they do in the settings they do, and why you get readings through a meter when the acceleration, it's not ions, the acceleration changes direction, or the direction at which the meter is picking it up or reading it. So we know the north-south push-pulls of this, as I explained. And, when this one's pushing out, this one's pulling in. And when this one's pushing out, this one's pulling in. So that's how it alternates. It makes a cycle, but it cycles back and forth, alternating. And what I want to show is I've got this set to DC, but I'm hooked to the AC side of my converter. I'm hooked to the lines coming straight out of here. 2 of them. The A, the positive red, into the meter on the positive side is on the A leg, and the C leg is hooked to the negative on the meter. And we're on DC, like I said. And I'm going to turn the handle and watch what happens. Negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, positive, negative, negative. So it jumps back and forth, but it's not consistent. And it's just like the Lord Kelvin's did. Exact same thing. It's not ions. It's directions that this thing's reading the current. And like I showed you when I hooked the DC current up on the DC side, when I swap the leads, it changes the reading, just like the battery and the magnets did, and even Lord Kelvin's. And what this is doing is since my RPMs are not perfect, it gets a little jolt in it. It's not perfectly going. So as this meter picks up the readings, when you see a positive reading, it's reading what's coming out this red one into the meter, coming out the black side of the meter, and going into south pull. So the north push out the red into the meter, and the south pull from the black gives me a positive reading. Now when it switches, because of my RPMs aren't perfect, if I had perfect RPMs, it should stay on AC or DC, one or the other, whichever one is dominant on the north push, the south pull, at the timing that the meter's picking up. But since when the black one's pushing out and it comes around the black side, it's going in the meter here, and I get a negative reading because the red one's pulling back in. That's the same thing that the Lord Kelvin's was doing. If you remember, it would go negative, positive, negative, negative, positive, positive, negative, and positive. And on both sides would just do that. Whatever they were doing, the meters were picking it up. That's the same thing here when you put an AC on a DC setting. And I had DC setting for the Lord Kelvin's so I could show you this. And I'll turn it again. You'll see negative for a while, and it'll jump to positive, and then jump back to negative. And it won't stay the same. And that's mainly because my RPMs are not perfect because I'm using my hand. But the point on this was that's what the Lord Kelvin's is doing. It's not ions, positive and negative ions. It's just whatever this meter's reading, especially on a DC setting, whichever one's coming in and going out, or coming in and going out, determines your positive or negative reading. But anyway, wanted to show that I can get negative and positive readings off of an AC output, setting the meter to a DC, and as I'll show you next, is why the meter does that. Okay, to prove that, I've got this set on 200 volts AC, and it's showing 124 volts, 0.2, 0.3, 0.2, and I'm hooked up basically backwards. I've got the black one to the black wire, you know, your hot wire of your AC side, and the red one to the neutral, and it's showing an AC reading. Now I'm going to swap these two, put the black one over there, the red one over here. Oops. And where am I? And we got 124.87 volts, and it's AC. So like I said, an AC current, even in your house, that's what this is hooked up to, it's back and forth real fast, 60 times a second. But this meter only reads the red side coming in, even though it's going in this one, out that one, in this one, out that one. It only reads this side. So that's that. But I'm not going to put my meter on DC to read this AC because it'll mess my meter up, and I'm not buying another one. If you want to try it at home, you can. You can hook this up DC and put it in there, and you will get a negative reading back and forth if it catches it right, but you'll be able to burn your meter up putting the AC current into the DC settings at this high voltage. I can do it on my little generator because it doesn't hurt it. Anyway, that's why that does that. The way the meter's set up on AC and DC. It's not ions, it's the directions of acceleration. Laters.